Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hello, everyone. Welcome to this session. Really excited to be here live. I am Pamela Fox. I'm a Python cloud advocate at Microsoft, which means it's my job to help Python developers be successful with Microsoft technologies, whether that's Azure or VS Code, Copilot, SDKs, whatever it may be. And of course, a lot of times it's AI. So today I'll be talking about prototyping AI agents with GitHub Models and Python using some of the most popular Python AI agent frameworks. So hopefully this session gets you inspired into thinking that you can start hacking on agents for free today. So first, we're going to talk about GitHub Models. All right, so we'll talk about GitHub Models. We'll talk about using GitHub Models with Python, and then we're going to dive into 4 of the AI agents frameworks and also mention a couple other frameworks as well, and then talk about like how do you pick a framework, right? So many options. What do you choose? If you are already using a framework, feel free to put in chat what your experience has been, what's your favorite, so that you can share your experience with other people, right? We're all here learning together. We need to share what our experiences are so that we can learn from each other. So we are going to be using GitHub Models today. If you haven't experienced GitHub Models yet, they are a bunch of free but powerful generative AI models, and all you need to use them is a GitHub account. So you go to github.com/marketplace models, and I'll go open that up over here. github.com marketplace models. So this brings me to the GitHub Models marketplace. And if you're signed into GitHub, you should be able to do this as well. And so for here, you can select a model in the dropdown. You can also click on View All Models. And that way you can see a list of all of them with some filters. You can sort and see, what got added the most recently. Whoa, we've got 4.1. I have not even messed with that yet. Gosh, maybe we should use that today. Okay, so we've got 4.1 mini, nano, 4.1. So this is like a really easy way, like when some new model comes out, if we add it here, you can start using it immediately, right? So let's go ahead and try out 4.1 and see how that's working. Oh, here we go. All right, so going here. All right, so once we select a model, you can open a playground for it. Right, so here's a playground. So we can go and just say like, okay, let's see. I mean, we have some examples here, but I need something more practical. How can I get my toddler to stop pinching me? Let's see. How smart is 4.1? So far, no doctor has been able to tell me yet. Yeah, do that. All right. Okay. All right. Wow, that was really fast. Okay. All right, so we got back the response. It was very fast, very long, pretty good, well formatted. And I'll see if there's any of these tips I can use here. Now we can also mess with the parameters, right? So we can change parameters here, like the system prompt, like, always reply in Spanish, right? So if I wanted to have like a Spanish user, like, hola, quiero practicar mi español, right? And here we can see it's going to respond. And even if I say like, hi, okay, Spanish is so hard. It should hopefully respond in Spanish. Yeah, and it did, right? So it's responded in Spanish because I said system prompt, always reply in Spanish, right? So this is where we've got our, general guidance. We can specify other parameters. Looks like temperature is 1 right now, which is actually quite high. I'm surprised that that's our default. Normally, for like RAG, I use like 0.2, 0.3. For more creative things, I'll use like 0.7. 1 is pretty darn high, but it also depends on the model. So maybe for 4.1, maybe 1 is a good default. And then we've got a few other parameters as well that I don't usually use. So you can play around with any of these models here and, get a feel for how they work. You can also, for the multimodal models, you can, go ahead and upload something and ask questions about it. So lots you can do in the playground itself. But here we're going to talk about code, right? So how do we use these models in code? So I click on use this model. And here we get this pop-up and it has some important drop-downs. So there's a drop-down here for the language. For some reason, it defaults to JavaScript. Obviously, we want it to default to Python. So we're going to change that to Python since we're here to do some stuff in Python. You can see it also has C#. I know some of you in the chat are C# developers, so shout out. We got Bruno in the chat. We got Java. I was raised on Java. My dad raised me on Java. We got REST, of course, which we can all use. So you can pick your language, pick your favorite here. And then you can also pick SDKs. So for Python, there's actually 2 different SDKs that you might want to use. There's the Azure AI Inference SDK, and then there's the OpenAI SDK. So once you click on one of those, then you get instructions for how to get started with it. The first thing is to create a personal access token. And so I'll actually show you the process here so that you can see how you would do that, right? So you go to like github.com and then you go to your settings, and then you go down to developer settings and you go to personal access tokens and you say generate a new token. And of course, you've got 2-factor enabled. So do you go to your authentication app and get your code? Okay. All right. And then we just say like, okay, GitHub Models test. All right. And we don't have to give it any particular access. It doesn't really need access to any repositories. So we can just click generate token and it says it'll expire a month from now. All right, so these are short-lived tokens that we can use for, about a month at a time in this case, right? So then we can grab this token and then, store it somewhere, right? So in this case, like maybe I'll put it inside a, I'll put it inside a .env file so that I can reference it as an environment variable, or you could export it into your environment. So that's how you create a personal access token. So that's what you need in order to be able to use these models from a development environment. And then once you have that, then you can start actually writing code. All right, so I'll review that because sometimes I go too fast, right? So we're in the playground. We click use this model. We select Python. We select an SDK. We get a personal access token. And I think this link here just directly goes to where we just were. Yeah, that'll just go directly to it. And then we've got instructions here for the actual code. So this is the code we're going to use. I've set up a repo just for today, or well, that you can use in the future too, but I've set up a repo specifically for experimenting with agents. And so that's what we're going to use today to explore this code. So let me get into that. So I did have some slides here just to mention that there are so many different models that you can pick from with OpenAI, with the GitHub models, right? So we do have the OpenAI models, but we've also got other providers. We've got Cohere, we've got Mistral, we got Jamba, we got DeepSeek, we got the Phi series, we got Llama, Codestroll, right? And so we've got large language models, we've got the smaller language models, like the 8 billion, 4 billion, 12 billion, that level. We've got ones that are specifically reasoning models, like the O1 and DeepSeek R1. We've got multimodal ones where we can upload images. We've got ones specifically for generating code, like Codestroll. And then we have embedding models, which are useful for developing vector search solutions or RAG solutions. So all of these are available on GitHub Models. And so as you see, this is how we can get started. And then this is how we can get the instructions for setting up the personal access token and getting that code. All right, so that is GitHub Models. Now, once again, they are free. They do have rate limits, however. So let me go ahead and get the rate limits documentation to put in the chat. Looks like I'm in Spanish here. Let me change that to English for here. So here is the rate limit documentation. So you can see it does actually depend on the model. Some of them have higher rate limits and some of them have lower. So if you run into the rate limit on one model, you may want to switch to another model, and so that you can use up all the possible quota. All right, so for today, in order to use GitHub Models with Python, we are going to use this repo, which we put in the chat. So what you can do is open this up. And we'll go to this repo here, right? So we open it up. Let's see. There we go. And when you open up the repo, you're going to click code. And I already have a code space open. But when you don't have code space open, you should see a big green button here that says make a new code space. And then you click on that. And I'll just make a new one just so you can see the process of it starting up. So I make a new code space. A GitHub Codespace is basically a VS Code in the browser, but loading that project with its environment. So it's actually loading a Linux machine with Python installed and with all the requirements installed, so that it should be really quick for you to get started. So here we can see it has loaded, and it just opened up that README. All right, and I'll just make this a little bit bigger. So now that the code space is loaded, and it's got everything I need, it's got Python, it's got the frameworks, right? You can see here that it has Python. So I should just be able to use the code. So the first example I'm going to open is this Azure AI / GitHub Models. And this example uses the Azure AI Inference SDK. So I installed this with pip install Azure-AI-Inference. So that installs that SDK. So this SDK does come from Azure. It's an SDK that we made specifically to work really well with any Azure hosted AI models. So that includes GitHub Models, because GitHub Models are actually hosted on Azure. It also includes all the models that are in the Azure AI Foundry model catalog. So, all the ones we just saw, plus more models, like, all the Cohere and Llama, all that. So if you are working with those models, this is a nice SDK for working with them. So what you see is that we do some imports. We create a chat completion client. Now, what's really important about this client here is to see how we configure it to work with GitHub Models. So here, what you can see is that we've specified an endpoint. So the endpoint for GitHub Models is models.inference.ai.azure.com. So that's the endpoint for GitHub Models, because in fact, GitHub Models are hosted on Azure AI. So we specify that endpoint. And then for the credential, we need to pass in our GitHub token. So we say, all right, get the GitHub token out of the environment variables and pass that in as a key credential, right? And what's interesting is that in this environment, whenever you're in a GitHub Codespace, the GitHub token is always set as an environment variable. So we actually don't have to go and make one. It's already there. So I could actually echo out my my GitHub token here, right? I say echo GitHub token, and there it is, right? All right, don't steal it. Okay. So when you open a GitHub Codespace, GitHub token will always be there for you. So you should be able to just use this in any code space. Now, if you're developing this locally, because I was saying I also have this repo open up locally, then I'm going to put it in a .env file and load it from there, right? So if you're in a code space, this should just work. If you are not in a code space, you need to create a personal access token and store that for your local use. Okay, so we've set up the chat completion client, and then we say, all right, here's our messages, and then we pass in the model. So here you can see this model name here, this model identifier. This needs to match what we find on GitHub Models. So if we go back to GitHub Models here, when you say use this model, and we check out like the pop-up that comes up, when you scroll down here, you can see it says GPT 4.1. That is the string that we need to use when we're coding with this. So I go here and like, okay, let's, well, first let's try it with GPT 4.0, make sure it's working with GPT 4.0. So I'll just go and run that there. Make sure that's working. Okay, so that worked. And now we can go and try a different model, right? So this is what's really cool about GitHub Models is that it should be really easy to try a different model. All right, and as you can see, these models are different. Like one of them responded with Markdown and the other one didn't. It's up to us whether we want it, if we like Markdown or not. But we'd always tell it responds in Markdown with helpful emphasis. We'll see if that'll change how 4.1 behaves. That's always the interesting thing about changing. Yeah, there we go. From one model to another is that sometimes you have to like subtly change your prompt to get similar behavior. So in this case, I was able to get 4.1 to respond more like 4.0 if that's what I wanted. All right, so that's with the Azure AI Inference SDK. Now, many people are used to the OpenAI package, right? This was like the first package that we had for working with generative AI models. It's a very popular package. It's what many people know and love. So this is often what I use as well. So let's see what it looks like with this package, right? So here, I'm bringing in the OpenAI package. And similarly, I set the base URL to that GitHub Models endpoint. And then I pass in the GitHub token as the API key. All right, so it looks really similar. It's just different parameters to customize it. And this is what you're generally going to find is that most of these packages have some way of customizing the base URL and customizing the authentication that gets passed in. And then we can go ahead and pass in our model name here. And once again, we could change that to 4.1. Here we go. And send off this request here. And here we go. All right, so that is the basics of using Python with GitHub Models is that you do need to pass in the correct endpoint and pass in your GitHub token. I see a question from Robbie, not using AI Toolkit in VS Code. I don't know if I have that installed in this profile. I actually don't use AI Toolkit very much myself, but it is certainly a good extension that you can check out, especially if you enjoy, having lots of extensions for your VS Code. So it looks like actually I do have it installed right now. So here you can see, if you want to check it out, it is the AI Toolkit for Visual Studio Code. And it gives you some options over here. It's probably this one with the sparkle on it. Yeah, there's the sparkle. Yeah, so it actually does make it particularly easier to like, it kind of puts the GitHub model playground inside inside your VS Code. So if you want to like have the playground just inside your VS Code, you could do that, right? So if I wanted to go ahead and like kind of add that in there, right? So then I get the playground inside here. Then I gotta like sign in with GitHub, okay. All right, here we go. Right, so I'll just say hi, right? So there we go. So now we've got the actual playground inside VS Code. So yeah, if you want to have that playground experience along with other functionality inside VS Code, check out the AI Toolkit extension. Cool. All right, great plug. All right, so we saw Azure AI Inference, GitHub Token, OpenAI, and one thing I want to show is function calling, because it's really the basis of a lot of agents. So I have this, this example here, which sets up some tools or functions. And these are basically functions that we're saying that we're telling LLM like, hey, LLM, here's some functions that you could call. The name is lookup weather. Here's the description of the function. Here's the city name. Here's the zip code. They're both strings. Here's the description, right? And then we have another function it could call lookup movies. It takes in a city name and a zip code too. And then what we do is, we have our normal conversation. But then we pass in these functions as tools that it can use, right? And then if the LLM thinks that like, oh, the best way to answer this question is to use one of those tools, then it will tell us that in the response, right? So let me just run this here. Okay, and so it actually recommended that we call both these functions. So it said like, okay, we think that you should call lookup weather with the city name of Sydney and lookup movies with the city name of Sydney. Now it's up to us if we actually do call the function. The LLM just tells us what it thinks we should call. It's up to us if we actually call it. But this is what's known as function calling or tools. And it's really the basis of a lot of the agent frameworks. But it's also a way that, if you want to, you can basically build an agent yourself. Because a lot of times when we think of an agent, we're thinking of tools, like we're thinking of, empowering an agent with tools where it can look up stuff, it can take actions, right? There's this, strong association between agents and tools. So what I want to show here is that, we're going to be using agent frameworks, but behind the scenes, what many of them are doing is basically using this function calling ability of LLMs and telling the LLM like, hey, based off this content, what function do you think would be good to call at this point? And what arguments would you send to that function? And then the agent framework can take care of actually calling that function, right? And that's what an agent framework can really do for us. So that is the, basic uses of, using the OpenAI SDK. So now that we've talked about that, we are going to move on to Python AI agent frameworks, because that's what we're here for. We're going to be experimenting with 4 frameworks today. We're going to try and squish all these in. You know me, I always like to squish a lot into an hour. But there's just so many cool things to explore. So we're going to explore the OpenAI agents package, which is different from just the OpenAI package. It's a newer package. We're going to explore Pydantic AI. We're going to explore Autogen, and then finally check out Semantic Kernel. So for all of these, we're going to be able to use them with GitHub Models or with Azure OpenAI. I've actually, if you look at each of the demonstrations, I've made it so you can use it with either GitHub or with Azure OpenAI. So that way, when you're prototyping at this stage, when you just want to experiment, when you don't want to spend any money, you can use GitHub Models. But if you do want to move to production and you actually want to deploy a model, then you could use Azure. And this is what's really cool, is that all of those frameworks we can use with GitHub Models or with Azure OpenAI. They are all flexible enough that we can use them with many different models. It also means that if there's like a completely different model you want to use a framework with, you can probably use it with that model as well, right? Like I know the most about, all the Microsoft and GitHub and Azure models, but generally these frameworks tend to be flexible enough that you can point them at anything. You can also point them like a local Olama server, right? Like I've got my Olama server running over here, right, locally, right? So that would be another option for low-cost experimentation, would be a local server with a decent model that can do function calling. So I have a blog post that shows basically, what is the key to using all of these frameworks with GitHub Models. But basically, we just have to figure out how to say, hey, we're using a model that has an OpenAI compatible API. And then we just have to modify the base URL and the key, right? So we've figured it out for every framework. But if you have some other framework that I haven't covered here, hopefully you can figure it out for that framework as well. So let's start with the OpenAI agents example. And to reiterate, all of these examples are in this repo, which is public, right? And so that all of you can actually use these examples and even follow along if you want. So let's start with OpenAI agents. All right, so I was saying this is a fairly new SDK, which is an agent-focused SDK. It's OpenAI-agents. That's how you would install it. And it's, it's interesting because it can bring in the OpenAI SDK, but they did actually design it so that you could use it with multiple models, right? So it's more model agnostic than the OpenAI one itself. So they made it so you can use it with different models, different tracing providers. They made it with more flexibility in mind. So for this one, the way that we use it with GitHub Models is that we construct this async OpenAI from the OpenAI package itself. And then we're just going to pass in this client. And it understands how to work with an OpenAI client. So then we create an agent. So this is how we create an agent with this package. So we say, here's the name of the agent. Here's the instructions. That's basically the system prompt, right? So here you're a Spanish tutor, only respond in Spanish. And then we pass in the model. So we say, hey, we're passing in an OpenAI like model. Here's the model name and here's the client. So that way it knows which model we're working with, and it knows about the base URL and the endpoint and all that stuff. And that is the basic agent, right? So the interesting thing here is that really, what is an agent? If you look at these frameworks, an agent is an LLM that has a name and instructions. So it has like a particular purpose, but that is the basic agent is really just a named LLM that has a specific goal, right? So here, if we go ahead and run this one, right? Let me just run it here. All right, so I said, hi, how are you? But if the agent is doing its job, which it is, it says, hola, ¿cómo estás? Right? So it has responded in Spanish because that's its one job, is to respond in Spanish. So that's the basic agent. Now let's look at tools, because it's saying like a lot of times when we think of agents, we think of tools. And I see there's various questions, in the chat about, how do we actually do function calling in tools? And, we're going to see different approaches across different frameworks, but let's take a look at how we do this in OpenAI agents. So if we go down here, the way we do it in OpenAI agents is that we define our function, right? So here I have like the get weather function. It takes in a city and it returns a string. And I decorated it. So this is what's called a decorator in Python. And this decorator comes from the OpenAI agents package, right? So you can actually see I imported it from the agents package, right? So from agents import function tool. And so here I've decorated it to say like, hey, this should be treated as a function calling tool. And in this case, I'm just returning fake data. But in reality, we'd want to go out to an API and get actual weather. But for this demo, we're just returning some fake data here. And now we have another function tool here, which is get activities. So this one takes in city and date and returns back some, fake activities as well. And then we also have a tool for getting the current date, right? So, if it's looking up activities, it needs to know actually what date it currently is. So this just, uses datetime.now in order to return the current time, right? So some of your tools will be going off to do like API calls. Like, so this get weather, that would probably be a weather API. Get activities would probably be like a database call, right? Like maybe Postgres or SQL or whatnot. And then get current date is actually just like a computation that we can do in Python, right? So when you're setting up tools, there's many different kinds of tools you can have, and they'll all use different functionality in order to achieve their goal. All right, so then I set up an agent and I say, okay, you're a weekend planner. You help users plan their weekends, choose the best activities for the given weather. If an activity would be unpleasant in the weather, don't suggest it, and then include the date of the weekend in your response. Okay, and then I pass it get weather, get activities, and get current date. And then I pass it the model that points at GitHub Models. And then finally, when I want to run it, I use this runner from the agents SDK. I tell it to run the agent with this input. So I said, okay, what can I do this weekend in Seattle? and then print out the output. All right, so let's try this out here. All right, and I logged out. I did add logging so we could see what was going on behind the scenes. So you can see it first got the current date. So it knew that the first thing it needed was the current date because it needed that as kind of a dependency for a future tool, right? So first it got the current date, then it got the weather, and then it got the activities for April 19th, which would be 4 days from now. So it got the current date, and then using, LLM math, it figured out that, oh, okay, if today is April 15th, then 4 days from now is April 19th. So we're going to look up activities for that date, right? And then it says, okay, this weekend it's expected to be rainy, of course. And here's what you can do is a museum visit, right? All right. So then, but like if we send something else, so let's say we're going to say San Francisco, I'm also just going to change my randomness so that to make sure it's sunny, because it's very often sunny in around here, San Francisco. Well, it's sunny where I am, maybe not in San Francisco. Okay, so it's getting weather. And it's interesting. Look, this time it actually decided to do a call for April 19th and April 20th, which is a good idea because usually weekends are 2 days long. And it's interesting that it didn't do that the last time. But yeah, it says it'll be sunny. And here's what you do. You could do the beach, you could do hiking, you could do the museum visit, right? So what you can see is that it did do, using the OpenAI agent framework, it did basically call tools sequentially in order to answer it, right? So you can imagine it's basically in a loop where it's saying like, all right, I got that information. What do I need next? I got that information. What do I need next? Let's see. I have, the kind of this visualization of it, right? That, this is our general architecture. This is a single agent architecture, right? We currently only have a single agent, but it's still interesting because of the tool use, right? And because of how the agent SDK is making it easy to call those tools in turn, right? So basically this LLM can keep going out and making calls to the tools until it decides it's made an end state, right? And this is a pretty common flow that you want when you are doing single agents with tools, right? So in this case, we have the weekend planner, and it can call out to any of those tools until finally it doesn't have a tool call anymore and it gets a response, right? So you can imagine that in the SDK, it's probably doing calls until it gets an actual text response and then says, okay, we got a text response. Now we're done, right? Okay, so the question was, were there multiple calls between LLM and tools? All right, so let me go, let me just go ahead and put this on extreme logging mode here, so that we can see all the calls that went out. So pro tip, if you want to really see what's going on, you can set your logging level to debug, and then you should see everything that goes out. So we can actually get a feel for how the agents SDK is actually doing it. So let's see. So when it should show, okay, so here, we can see the first response, request that goes out is, passing in all those potential tools, right? This was the function calling. And it went out to GitHub Models. We got back a response, right? Then we sent out, then it's another one where it got the response that it should do get current date. And then you can actually see the full, it's sending all the current tool calls and getting back the next one. So it's making quite a few calls in order to finally, get the response. And I can't really count just at a glance how many calls it's making. But basically it is making a bunch of calls in order to, to get back all those tool responses and then finally get to the end response. The logs are quite long, but if you want to go deep, you got to go debug mode, and then you can see everything. And here I'm also using the rich handler, which is really nice. So every framework is going to be slightly different in, how it kind of does this like coordination of the tool calls. So if you want, you can like dig into debugging. You can also look at the documentation to see exactly how it does it. Because we have like 4 frameworks to show, we can't go super deep into it. But I do recommend, going more into their docs and into the debug mode in order to see how they did it. But the general idea is there are a lot of chat completion calls that are happening, right? It is more than just a single one. Now, you could potentially, like, you might say like, oh, why can't we do all these in once? Well, in this case, we couldn't because get current date is a dependency for the other 2. But also generally parallel, that's what's called parallel tool calling, like getting multiple function calling suggestions at the same time. Generally, that's just a lot harder for the LLMs to do. So a lot of times they'll, these agent frameworks will try to just do one function call, one tool at a time, because it just tends to be more successful than trying to do 2 at once. Yeah. So in this case, you can imagine that basically it says like, okay, here's your tools. What's the next one we should call? All right, great. We got that. We got the response. All right. Now here's the full conversation so far. All right. We got, we called this one. We got this response. We called this one. We got this response. We called get weather. We got this response. We called get current date, called this response. And what's the response, right? And then finally, we get back the text response, right? So in this final call, once we'd made all those tool calls and got all those responses, the LLM was like, all right, now I can answer this question. But it needed to see all of the, it needed to see that it already had made all the required calls and that it had all the information. Okay. All right. So there we go. Single agent with tools. And even that is interesting in itself, right? And I think that they did a nice job with, making it easy. If this is your scenario, a single agent with tools, this framework makes it pretty easy to do. Now, let's move on to a multi-agent architecture. So here is a what we'd call like a supervisor agent architecture. So in this case, we have the supervisor agent, and that one decides which of the specialist agents should handle a task. And each of those specialist agents can also have one or more tools that they can call, right? And they can also share tools too, right? So there can be, different relationships between the tools and the agents. But this is a very common architecture that people use, because generally what people find is that when you have agents that are specialized, they just tend to do a better job because they get less confused, right? They, hallucinate less, they stay more focused. If they have a smaller number of tools, like it's easier for them to know which ones to call. So this is a very common multi-agent architecture, right? So the example we're going to look at, we have a triage agent that's either going to send stuff to a Spanish-speaking agent or an English-speaking agent, and both of them could call get weather. And I like this example too, because you might have an LLM that's really good at Spanish, and then you might use a different LLM for speaking Spanish than for speaking English, right? Especially as you get into, like CJK, like Chinese, Japanese, Korean languages, right? I can definitely see there being some LLMs that are better for that than are, like the GPT ones. So let's look at that example in code over here. All right. So going over to that example. So here we've got the agent. We got Spanish agent, English agent. Oh, I don't need this weather agent. Delete that. Okay. So we got Spanish agent, English agent. Each of them has the get weather tool. So that's up here. And then the triage agent, what it has here is handoff. So it says it can hand off to either Spanish or English, right? So the supervisor knows who it can delegate to or hand off to. All right. And then, and I was saving it. It's cool. You can save out the visualization of it. But let me comment that out. But if you like to see your visual, you want to see your agents visualized, you can actually save it out, which is really cool. All right, so then I put it in input. So let me go ahead and run this. Oh yeah, let me get rid of my GraphViz stuff here. Okay. All right. So, and we sent a message that was in Spanish. So the assumption is that it's going to send that to the Spanish agent. And well, it looks like it did, because it did respond in Spanish. We could probably add some debugging and logging to check that. But that's the idea, is that it could hand off to different ones. We could change this to like pirate agent. You only speak pirate. Okay. Let's try this. Matey, what's the weather? See if it's gonna hand it off to. There we go. Tell me your city. Oh yeah, I forgot, in my city of San Fran. I don't know how pirates say San Fran. There we go. Perfect for sailing the bay. All right. So there we go. So the way OpenAI does that is using this handoffs parameter here, right? So with any agent, you can say, hey, this agent can hand off to the other ones. And, basically it's going to send information about the agents to the triage agent and say, all right, here's the possible agents you can delegate to. Which one do you want to delegate to? So that was a brief introduction to OpenAI agents. And it does have lots of support. I know there was a question about MCP support. It does have support for MCP servers. It also has support for guardrails, for tracing. We can't dig into all of that today. So if you do want to learn more, just head on over to their documentation and check it out. I think it's a nice lightweight framework, and that it could work really well, especially if you're already using the OpenAI SDK and you just want to move to something a little more agent-like, especially, to help with, function calling and tools. Then it could be a really, really good fit, right? So now let's move on to Autogen. All right. So with Autogen, we can connect to GitHub Models by actually using, they have a kind of client that wraps OpenAI compatible endpoints. So we use that to connect to GitHub Models. And then we can set up an agent. And once again, an agent has a name. In this case, the names have to be valid Python identifiers. So I said Spanish_tutor, and then a system message, and then the model. So immediately you can see this is actually really, really similar to our basic, OpenAI agent example, right? So we got our name, got the model, we got the system message, right? And then we can tell it, here's our text message, and we can run that and, get the response here. And it should respond in Spanish. That is okay. Estoy aquí para ayudarte. Okay, so it's working. All right. So that is our basic Autogen setup here. Now, of course, we want to, use some tools. Now, in order to use tools in Autogen, it's actually a bit more complicated. So first, I need to introduce this agent architecture called the round robin group chat. This is a group chat orchestrator that's from Autogen. And the idea of it is that each agent broadcasts to every other agent that's in the chat. They take turn responding, and they take turn as a round robin. So first you have agent A, then agent B, then agent C, then agent, that should be D here, right? Until finally you get a termination condition, right? So at any point, the termination condition could happen and the chat would stop. So in order to do the same thing that we just did with OpenAI Agents SDK, we actually need to use the round robin group chat with a single agent, right? So it's basically going to be taking turns with itself, calling itself multiple times, but each time potentially calling a different tool until finally the termination condition is reached. So this is, you can also think of this is kind of the way that the OpenAI Agents SDK was doing it, right? It was like you could continually call an agent, calling different, different tools each time until finally, you'd exhausted all the possible cool calls and you had a response. So let's take a look at what the code looks like for that one. So Autogen _tools. All right. So we've got the same, same function, get weather. In this case, we don't do a decorator. We just define it as a Python function, no decorator. Get activities, same thing, no decorator. Get current date, same thing. We have an agent. We pass it the tools. But if we only just call this agent once, it's actually only going to make a single tool call. If we want it to do, what we saw before with calling tools potentially multiple times, then we need to set up this round robin group chat. So we make the chat of just the agent talking to itself. Yay. We give it a termination condition. And so this tells it when to stop. And in this case, it will stop as soon as it gets a text message from this agent. So a text message as opposed to like a tool call message, right? So if it sees a tool call, it's going to keep going. But as soon as it gets an actual just plain text response, it'll be like, oh, okay, the agent has made its final answer, and then it'll end, right? So that termination condition makes sense for this. And it's basically going to achieve the same thing that we did with the OpenAI agents. So I'm going to run with this chat message here. What can I do for Funzy this weekend in Seattle? And I did some logging just so you can see what's happening. And then I'll print out the response. So let's go ahead and try this out here. All right. So we can see it is calling the get current date function. So it's calling that first, calling get weather up here, then getting the activities for Seattle for April 19th. So this should look familiar. And then it should hopefully have what it needs in order to respond. So it's working on its response now. I see the question, how does it know which tool does what? So in this case, it gets the information from, the function name, the parameter name, the arguments, the return value. You should also be able to do a doc string to provide more information. So I think if you put a doc string in, fetches the weather for the current city, right? So then it, should look at that information too. So generally what these frameworks all do is that they look at your functions and extract as much information as they can about them in order to come up with this same thing here, right? So when we actually use this at a low level, we have the name, we have the description, and we have the properties with their strings, right? So you can come up with all of this by looking at the function name, the function arguments, the function return value, and the function doc string. So the agent frameworks will try to get all that information and then turn it into a schema to send to the LLMs. I don't know why it's being slow here, so I'm gonna just put it out of its misery. I'll go ahead and run this one locally here too. So I've got it hooked up here as well. Okay, and then yeah, so that's a great question. So if we name it using poor naming conditions, it might not work. That's a great point. This is a great motivation for us to make really good function names, really good parameter names, good types, good doc strings. And same thing for those of you developing MCP servers, MCP tools. This is great motivation to follow conventions, do what's going to make sense, be descriptive, be thoughtful, and because we're trying to communicate to the LLMs, and if we're really specific, then they can be more specific. Let's see. Okay. Okay. All right. So here we go. So I ran it locally. All right. So we got a response here that said we should visit a museum because everything else is too rainy. So we basically achieved the same thing that we did with OpenAI with a little bit more work. However, with Autogen, you have a lot more orchestration options, right? So there's a lot more you can do with round robin. There's more flexibility, right? You can do a different termination condition, right? So I saw a question, can you set your own termination condition? Yeah, so you can say oh, when the LLM responds with this, then that's terminating it. Or if you had a certain a max turns, there's a lot of flexibility with that termination condition, right? Okay, so we saw that example. But I was saying Autogen has a lot of orchestration architectures, and one of the ones that is really cool is Magentic One. This all comes out of Microsoft research. So there's actually a research paper you can read about this. And they basically found with this Magentic One orchestrator, they were able to have really good results. And this is kind of like a really good supervisor architecture, right? So basically Magentic One is a supervisor agent that is keeping track of a lot of things, right? So it has like a task ledger, which is all the tasks it thinks it needs to do, like all the facts it needs to get, like what its plan is, what's missing. It has the progress ledger, which is checking to see, how, what progress it's making, what agent it thinks it should call next, what instructions said the agent. It's checking the termination conditions. And if so, we get the result. Otherwise, it's going to keep on calling agents and even potentially stalling. I don't know how you can figure that until it gets the result. So this is the Magentic One orchestrator here. So we can, basically, it's another kind of group chat. So let me open up my example of Magentic One. Right. So here I'm doing a like travel planning where I've got like a local agent, a language agent, and a travel summary agent. And this one knows how to respond with a certain term. So it's going to respond with terminate when it's all done. And so then our termination condition is actually going to look for that. Right. So that's how I was saying we can do a custom termination condition. Right. So say like, OK, when we see that, then we're going to terminate. All right. So let me go ahead and run that one. So you can see we pass in the agents, we pass in our termination condition, and it's just going to come up with a whole plan, and it's going to, right, so here's the plan. It says, all right, we need to do this. This is the facts we have. This is what we need to look up. This is what we need to derive. There's some educated guesses. We're going to call local agent first, then we're going to call language agent, then travel summary. And then the orchestrator is sending its own requests to each of the LLMs where it's providing a lot more information and context, getting back responses from each of them. Let's see. And so it sends another one to the language agent, gets some Arabic phrases, and then finally asks the summary agent to summarize it all together. Right. So you've got a manager basically that's figuring out what are the right instructions to send to each of those sub agents. And then we get the whole summary. So that is Magentic One. All right. So Autogen, really, really interesting framework. It comes from Microsoft research. So it has a lot of cool orchestrations that are based in research papers. There's more than Magentic One. There's Swarm, there's Selector Group Chat, there's Round Robin, which you can use in various ways. It's got these tools, terminations, handoffs. So there's a lot you can do with that. And it's got a lot of these nice built-in orchestrators. And it also works pretty well if you need human in the loop orchestration. That tends to work pretty well with these group chats as well, because you basically just put the human in the group chat as well. However, it is an API that changes more frequently than other ones because it is from the research group. And so it may not be the right solution for a production app, but certainly for prototyping, if Autogen looks like a good fit for you, go for it. All right, we have 7 minutes left. Oh yeah, I squished way too much into this. We need like 2 hours for this because there's so much interesting things to explore in these frameworks. So I'll have to go a little faster. All right, so let's talk about Pydantic AI, right? So the basic example here, right, looks really similar to other ones. The only difference is that Pydantic is designed to work well with type annotations. So I did put in some type annotations to specify like return type and dependencies, right? So that's the big thing about Pydantic is that Pydantic AI, it comes from the creators of Pydantic. So it has really good support for Python type annotations. And so it could be really nice for you if you're already using Python type annotations and you really like type safety in your Python. Now, what's really interesting about Pydantic is that they've embraced a graph architecture. This was originated by LangGraph, another really popular framework. The idea of a graph architecture is that we've already seen many different graph, miniature graph architectures. But if you generically support building any kind of graph, then, as a developer, you can build out any flow that works for you. So you just say like, okay, here's all my nodes. And, this is how the nodes can call each other. And at a certain point, you need to have an end condition, right? Because you don't want to loop infinitely. You want your agent to eventually stop agenting and return, an end result, right? So that's what's really cool, is that you can potentially out anything. Now, it is a little bit harder originally to figure out how you want to lay out a graph. So I think these graph architecture frameworks are more intimidating, but it is ultimately more flexible. So here's an example of a graph architecture where the LLM is going to ask the user a question. I'm going to answer. The LLM is going to evaluate whether I did a good job. It's either going to reprimand me if I did a bad job and ask me a new question, or it's going to end. So we have that structured in a graph here. So what you can see is that we've got some agents, but then we've got nodes of the graph. So we have the ask node, the answer node, and that one's just getting response from the user. So that's just a user and a human in the loop there. We've got evaluate, and that uses an agent. And then we've got reprimand. So then we construct this graph with the nodes. We keep track of state so that the state can weave throughout the graph. So they can always update the state and reference from the state. And then we can run the graph. So let me go ahead and run that. All right, so it is running. And you know what's really cool about this one is that, once again, you can visualize it. So you can write some code to output your graph to a mermaid diagram. All right, so what's the capital of France? I'm going to do a bad job answering it and say Paris with a Z. And it says it's incorrect. All right, now it asks me a new question. Boiling point of water is in degrees Celsius. I should know this. 100? Good. Okay. All right. And then the graph ends. So we've reached the end state. That's the end node, right? But otherwise, it would keep going. Now, you can get much fancier with your graph. I tried to start with an example that I thought was fairly understandable, but you can really get much more complicated with graphs because potentially you can build, just really, really complicated graphs. All right, so when would you use Pydantic AI? It has lots of features, particularly good if you like, typed agents. If you're already using Pydantic, like if you're doing a fast API app, if you're using Logfire, which also comes from them. It is one of the newer frameworks. It is changing a lot, so you have to be ready for that. But it does seem like a really nice framework, so it's definitely worth checking out. Okay, so Semantic Kernel, last one to explore. And Semantic Kernel has its own set of group chats. So it has this agent group chat notion here where you add a bunch of agents to a group chat and you give it a selection function and then a termination function, right? So we've seen termination functions before. A selection function is a function that is in charge of deciding which agent is going to go next. And so that selection function could be really simple. It could be an LLM. Like it gives you a lot of flexibility here, right? So this is similar to other architectures. It's just kind of done a little bit differently, right? So if we look at the semantic kernel example here, we've got an agent group chat that has a reviewer and a writer. And the selection function is actually going to be an LLM. So we're going to say, okay, look at the response and choose the next participant. Here's your options. Here's some rules. And so it determines it. And then the termination function also is going to be an LLM in this case, where it says, okay, examine the response, see if it's satisfactory. And if so, you're going to just say terminate. And that's the idea of this semantic kernel group chat. I'll go ahead and run it. And this one does have a human in the loop, or at least at the beginning of it, right? So it's going to edit what I say. So I'll say roses are red, violets are purple. And it's going to bring in the writer and the viewer agents in order to iterate. So first the reviewer comes in, then the writer, and then the reviewer, and then says no further improvements are needed. So this was able to go back and forth, selecting, terminating, selecting, and terminating when it needs to. All right. Semantic Kernel has a ton of features. That was just one example of ways that you can orchestrate agents. It does also basically have a graph framework as well. It's called the process framework. So if you're looking for it in Semantic Kernel, it's called process framework. There's some examples in these links here. It does have MCP support. It also has really tight integration with Azure offerings because it is from Microsoft. So if you are integrating with Azure, it's a very good fit. It's also available in C# too. So if you want to have similar code across Python and C# code bases, it would also be a really good fit. And it's designed for production use. There's even more Python AI agent frameworks. So I have examples for these in the repo. So you can check out the lane graph example. That's a very popular graph-based framework. Llama Index if you're doing RAG. Smol agents if you want to use code to answer questions. That's a cool framework. Also Crew AI. I don't have that in the repo, but you can follow the tutorials online to start up a Crew AI project. And you can also use that with GitHub Models. All right, so you have lots of choices when you're choosing a framework. These are the kind of questions that I think through, right? Like, does it support the LLMs that you want to use? Does it support the agentic flow that you want, right? Some of them are not flexible enough for what you want to do. And some of them might feel too flexible at first, like too intimidating, right? So you kind of got to figure out what sort of flow you need. And whether you just want one of these built-in orchestrators that already works well for you. Does it support any other features you need, like streaming, tracing, and evaluation? How easy is it for you to use, right? You don't really know that until you start using it and debugging it, and then you kind of see what the developer experience is like. So that's why I think it's really good to at least try and spend an hour with each of these. Like with most of these, I've only actually spent an hour or two. It probably seems like I might know what I'm talking about, but I really haven't spent that much time with these frameworks. But even just spending an hour, you can learn a lot about a framework, right? It's like a date with a framework, right? So go on a first date with a framework, see how it goes. Are there security issues? That's definitely something you want to keep in mind, right? Anytime you're using somebody else's code, you want to look for security issues. How actively maintained is it? Are the people nice that maintain it? I always look at that. Generally, whenever you're choosing a framework, it's all about, are the trade-offs worth the benefit, right? Is the framework giving you a lot of benefits that otherwise would be a lot of code for you to write? And is it still making it possible for you to do what you want to do, right? That's always a decision we make when choosing any kind of framework in development. And some people may not use a framework at all. You might just want to use straight up function calling, what I showed at the very beginning, and you totally could. Right. If that works for you and you like, using that at the low level and you don't, need any of these other fancy things, then you can just straight up use the low level packages with function calling. Right. All choices. Now, all the examples I showed today, I used GPT-4o. However, in theory, you could use it with other LLMs that support function calling. I've had kind of mixed success with it. These are a list of ones that support at least basic function calling. So you can basically, you can just test it, point your code at this model, see if it works. If you get an error, try a different model. You need the LLM to support function calling, but sometimes you need the LLM to support other features too. So you don't really know until you try it with that particular framework. All right, so you can start hacking. And so once again, here's the repo you can start hacking on. I saw various questions about, how you deploy, right? So with GitHub Models, you don't have to deploy anything because they're already deployed and they're already publicly available. If you do want to deploy and use an Azure OpenAI model, then you can do that. I do have instructions in this repo for making an OpenAI deployment, right? So if you do want to deploy some Azure OpenAI models like GPT-4o, that's what this will do. So you can do AZ off login, AZ provision, AZ down when you want to take it down. And basically that'll just use the infra here in order to make some OpenAI models. So if you want to deploy an Azure OpenAI model, you can do that following the instructions here. But you can also get started using GitHub models that are already online, ready for you to use, freely available. All you need is your GitHub account. GitHub models are free. So if you use GitHub models, then you're not going to be paying anything, right? So saying they're free and they're rate limited. So that's how they're able to be free, is because they're rate limited. I always open it in Spanish. Okay, so here's we have the rate limits. If you do deploy Azure OpenAI model, then you would be then the pricing would be based off the Azure OpenAI pricing, which is generally the same as the OpenAI.com pricing. They tend to be the same pricing. So you can look at you can look at the stuff there. So it's like, depends on the model as to how much it's going to cost. All right, let's see. Okay, I'm sure I missed lots of questions. Okay, so let's see what other questions I can cover. Anna says I can take a few minutes, right? So once again, GitHub models are free. I'll put this link here. As your OpenAI models, if you were going to deploy those, the pricing should be similar to openai.com, and you can check the pricing page there. But you can just use these with GitHub models from your local machine, just following the instructions for setting up the GitHub token. All right, let's see if there are other questions. So Murillo asked, is this like retraining the model? So that's a good question about retraining the model. I actually did not do any retraining of the model for any of these, because if we were retraining, that's also what we call fine tuning. Fine tuning usually requires like, hundreds or thousands of examples, and it actually changes the weights in the model. Like sometimes just like the up higher levels weights, but it would actually change the weights in the model, and then you'd have your own model that you would then be running. I did not use a fine-tuned model for any of these. There may be people who are fine-tuning for agent use cases, but I think most people are just going with an existing model that works well, and then just doing everything with your, basically with your prompt engineering, like with your system, your system prompts and your function descriptions, right? And then you're able to give all the information that you need in order to get the response. So we're never doing any training, but we can be like providing, if we're like, we can be providing feedback and saying like, basically like reflection. Like one agentic pattern is reflection, where you say like, hey, agent, here's the response from this other agent. Can you tell me if that was a good response? And the agent can say, oh, that was a good response, that was a bad response. And then, you can decide to take another action. And that's a common agentic flow. So we're not training, but we are reflecting, and we're giving feedback to say, hey, that was a bad response. Let's come up with a better response. So there are ways that we can improve our, our outputs, by letting the model know, what it's doing well and what it's not doing well. Let me see where, just to show you that. Here's a diagram I made for Agentic RAG, which is, we've been working on a blog post about this, but basically like you can evaluate an answer, and if it gets a low score, you can then reflect and say, okay, why was that a bad answer? All right, do we need to do another search? Do we need to reformulate the answer? And that can improve your responses. All right, let's see. So so Logan asked, do we have a Microsoft Teams where you can collaborate and share info about these projects? We don't have a Teams, but we do have a couple different things, right? So we've got a Discord. I think there was a question about the Discord. So let me go ahead and put the Discord link in here. All right, so here's our Discord link, and we have office hours there. And I know a bunch of you come to those office hours. So the next office hours is going to be Thursday with me. It's actually at 1 p.m. Let me change that. So that'll be in the Discord. So join our office hours, and we've got a couple other office hours too. So there we go. So definitely come to the Discord. We also have, for the Agents Hackathon, we've got a discussion forum. So if you prefer posting in the discussion forum, you can post in that discussion forum. That's also where you can find teammates for the hackathon, all the session resources, say hi to everyone. So yeah, so join our Discord. Say hi to the in discussion forum. Those are all great options for connecting with other people that are hacking on agents. Let me see. So Yash asked about, if you're placing an online order and the AI needed to contact the human to verify or prove something, then you'd use Autogen. I think Autogen would be a great fit because it does make it easy to do human in the loop. But you could also, most frameworks do make it possible to do human in the loop. Like the Pydantic AI example I showed did have human in the loop as well. It was just one of the graph nodes was a input from the user. So yeah, I think you've got multiple options there. And I think it's great to have human in the loop. Generally, what we find with agentic solutions is that if you have a human in the loop, you can get to, much better accuracy when you can involve them for approving anything, especially anything that's ambiguous. You want to have the human approve that. Robbie says the Autogen session was scheduled. Yeah, we did have an Autogen session scheduled for today. Unfortunately, the Autogen team got sick and didn't have the voice to put on the session. So we won't actually have the dedicated Autogen session. Sorry about that. It's that time of year where people get sick. Even my throat was like threatening to give up today, but we made it. So hopefully we'll get Autogen to come back in the future to this YouTube channel. All right, great. Okay, so I think I managed to answer more of the questions. Once again, if I didn't make it all your questions, feel free to post it in the GitHub discussion forum, in the Discord, or just come to my office hours on Thursdays, and I'm happy to explore more. As you can see, these agents frameworks are super interesting. You've got lots of options. Just start somewhere, start anywhere, try something out, have some fun. You'll learn and see what frameworks you like and which one's your favorite, and you can come back and let us know. All right. Thank you, everyone. Hope to see you in the chat of future streams.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.